Hello and welcome back to my coding days. In today's video, we are going to dive into the fascinating world of types in C++. Types are fundamentals to any program since they define what our data mean and what kind of operations we can perform on them. So let's get started. Understanding the different types available in C++ is crucial for any programmer. It allows us to categorize and manipulate data effectively. Today, we'll dive deeper into the arithmetic types category and explore its significance in programming. Let's discuss some fundamental units of memory: bits, bytes, and words. A bit is the smallest unit of memory. Computers store data as a sequence of bits, each holding either 0 or a 1. Computers organize memory as chunks of bits, and the smallest addressable chunk is called a byte. A byte typically consists of 8 bits. The basic unit of storage, which is the smallest number of bytes, is called a word. In most machines, a word is either 32 bits, which is 4 bytes, or 64 bits, which is 8 bytes. Every byte in memory is associated with a unique number called an address. Each address is a hexadecimal number. Here, for example, these bytes have the following addresses. The C++ type system consists of the following types: the fundamental types and compound types. The fundamental types are categorized into 3 categories, namely void, null pointer, and arithmetic types. Arithmetic types, as the name suggests, are types that allow us to perform mathematical operations. They are categorized into 2 groups: integral types and floating point types. Let's break them down into simpler terms. First, let's talk about integral types or integer types. The bool type is a special type used to represent logical values. It can have only 2 possible values, true or false. Booleans are often used in decision making and conditional statements. Character types are categorized into narrow and wide characters, and narrow characters are used to represent individual characters such as letters, digits, or symbols. On the other hand, wide characters are used for representing symbols from larger character sets such as Chinese letters, or when dealing with multi-byte characters. Signed and unsigned integer types are used to represent whole numbers without any fractional part. Now let's discuss floating point types. They are used to represent numbers with fractional parts, such as decimal numbers or values with high precision requirements. Now let's look at these types in code. The syntax for defining a variable is like this. You should give the type and then the name of the variable. Let's start with integral types. The basic integer type is int. We use int and then the name of the variable, which it can be anything, and then a semicolon. We can use the size of operator to print the size of this type in bytes. So let's do that. Size of int is size of, and then the type. Okay, now let's build and compile this to find out what is the size of this variable. Okay. Okay, we can see that the size of int is 4 bytes. There are some modifiers to int. The first one is the signed and unsigned modifier. As its name suggests, we can, by default, it is an assigned, which means that this variable can hold negative and positive numbers. But we can use the unsigned modifier so that that variable will just hold the positive numbers, like this: unsigned int There is another modifier regarding the size of int, and that is short or long. We can define a short integer, which in terms of its size, it is shorter. So my short integer, or this is equivalent to just typing short, and there is another, or we can use long. Or if we even want more memory, we can use long int. Let's have a look at the size of these types. I'm just going to copy this line, and then here I want to have a look at the size of short int. Let me bring this to the new line. And let me just copy these. Size of long int. And finally the size of the long. Okay, now let's build. And run again. Okay, so the size of int is 4 bytes, the size of short int is 2 bytes, long int is 4 bytes, so by default int is a signed long integer, and the size of long is 8 bytes. And beware that we can use a combination of these modifiers. So for example, I can use unsigned long int to define a long integer which only holds the positive numbers. Unsigned long int. Okay, now let's have a look at character types. We use char to define a character type, so I can give it any name that I want, and we can have a look at the size of this character by using the same approach. Characters, the character type or char is usually used to represent the UTF-8 symbols. So let's have a look at its size. Let's build and run. Okay, it has a size of 1 byte, and so maybe I should remove this S. We can use the signedness modifier to define the character type. So I can use a signed char variable or an unsigned char. For white characters, we use the wchar underscore type. So I can put a name white character var. Let's have a look at its size. I think it should be more than 1 byte, so I will change this to bytes, and let me copy this. Oops, better not to copy. Okay, now let me save and build and run. Okay, wchar underscore t is 2 type. The size of wchar underscore t is 2 bytes. We also have some other types for UTF-16 and UTF-32 characters. For UTF-16, we use char 16 underscore t. Let me give it a name, UTF-16 var, and for UTF-32 you should have guessed that we use char 32. We can also have a look at their size with a similar approach. Let me duplicate this line, and 32. Okay, now build and run. Okay, we can see that the size of character 16 is 2 bytes and the size of character 32 is 4 bytes. So if we want to sort the size of character types from smallest to the largest, it is like the char and then w char and char 16 and char 32. The last type in the category of integral types is the Boolean type. To define a Boolean variable, we use the keyword bool and name, and we can look at the size of this variable type with the similar approach. So the size of Boolean is I think now you guess what is the size of this type. Terminal, build, and run. The size of Boolean is 1 byte. Okay, and finally let's have a look at the floating point types. Let's start with the single precision floating point type. To define a single precision floating type, we use float. To define a double precision, we use double. And for an extended double precision, we use long double. We can look at the size of these types. So float, double, and long double. Okay, now build and clear and run. Okay, the size of float is 4 bytes, the size of double is 8 bytes, and the size of long double is 16 bytes. Now that we are familiar with the types and how to define them in the code, let me give you some advices to use the types efficiently and appropriately. Use an unsigned type when you know that the values cannot be negative, and use int for integer arithmetics. Short is usually too small, and in practice, long often has the same size as int. If your data values are larger than the minimum guaranteed size of an int, then use a long. And don't use plain char or bool in arithmetic expressions. Use them only to hold characters or truth values. Computations using char are especially problematic because char is signed on some machines and unsigned on others. If you need a tiny integer, explicitly specify either signed char or unsigned char. And the last one, use double for floating point computations. Float usually does not have enough precision, and the cost of double precision calculation versus single precision is negligible. In fact, on some machines, double precision operations are faster than single. The precision offered by the long usually is unnecessary and often entails considerable runtime cost. Thanks for watching this video. I hope you have enjoyed it. Please don't forget to like the video and subscribe to my channel. Until the next time, happy coding!